Chat GPT.
GPT is a type of artificial intelligence,
which stands for Generative Pre-trained Transformer.
Accessible and free to anyone on the web that impersonates what it's read on the internet.
A state-of-the-art conversational AI model developed by OpenAI.
Today, we're going to talk with Xavier Garcia about Chat GPT. Xavier is a senior research scientist at Google working in NLP. Before working in machine learning, he received his PhD in mathematics from Northwestern. This will be the first of, hopefully many, informal chats with him. I guess one thing that would be interesting is just your perspective on the history of NLP leading up and up into Chat GPT. And to be honest, you can go as far back as you think you want to or don't want to.
Yeah, I mean, I think it sort of really depends on your own perspective. So I think there's two kind of main branches that led up to this. So there's a philosophical aspect of if you build an intelligent system, how do we actually align it to so that it actually does what we want and not in a dumb way, but actually the correct way. And then there's the actual ML aspects of how do we build intelligent systems, period, right? So I think OpenAI has been pretty futuristic looking since the beginning, right? They've kind of had this dream that large models trained on this raw corpus data could actually accumulate knowledge this way, but just doing pure self-supervised learning. And in fact, when they first had their first kind of paper in this direction with GPT-2, it was really bad. They hyped it up. They said it was this great model, and they showed that it could attempt to do serious child learning, but it was pretty bad. Right? The performance was not great. And I think most people would have kind of given up by that. They're like, oh look, it is not clearly working. Let's just give up. But they actually persevered, and then once they had GPT-3, it was actually clear. Hey, look, this is actually real. This is actually getting really good performance. Actually matching dedicated models on some of these tasks. And nobody really understood what that meant up until you actually use the API. And it was cool. You could do all these things that were kind of unimaginable. But despite this progress, you still keep seeing that these models, you have to hack them. You have to trick them into giving you what you want. You couldn't just ask them. Right? So that's because these models were really not aligned. So, but people in the community hadn't really come up with the idea of aligning models. What does it mean to get a model to do what you want in this way? People in sci-fi writers or more philosophical arguments had always this fear that you might build a model that, say, you trained it to build paperclips, and then it would accidentally in that process destroy humanity. Right? Somehow you want to align the model to also to human values, human purposes. And so I think this used to be kind of like a joke, or a joke's maybe too strong a word, but maybe it was more within the realm of philosophy, right? And then it wasn't really taken that seriously within the realm of actual traditional machine learning practitioners up until this Instruct GPT paper came out, where they said, well, what if we could actually train a reward model that encapsulates all the humans' purposes, or not all humans, but just the actual OpenAI researchers, let's say. Can we then somehow use that model to distill those human purposes onto the original language model, so that way it's more aligned with what we expected? And the result of that process was Instruct GPT. So OpenAI had explored this general idea of alignment models. So they did it with summarization, and they had done it even for RL, for robots. So the idea wasn't that new, but actually combining these two concepts of large language models trained on large amounts of data with this idea of alignment is what kind of created this idea of Instruct GPT. And then Chat GPT, we can think of it as the latest instantiation of that technology.
Okay, so can we talk a bit high level? Suppose I didn't know anything about language models. How is GPT, or Instruct GPT, which is the predecessor to Chat GPT, how is that trained? Yeah,
so first you get a bunch of text from the internet, and then you clean it somehow. So somehow you can read the paper and you can figure out what they mean by cleaning it, right? But obviously a lot of web text is garbage. So you throw away the garbage, and then you get a big transformer, and you train it to predict the next word. So you just give it words and you say, okay, predict the next word. So that's phase one. After a long time, you have some model. Okay, it's pretty good at next word prediction. So now let's put this aside for now. And then what you're gonna do is that you're gonna get examples of like what you want the model to do. So for example, it may be something like, tell me about the moon. And then you have somebody actually write down facts about the moon, right? Or tell me a story about a frog, right? And then you have somebody actually write down this story. Right? So you collect this human labels or human generated data on the exact task that you want the model to do, right? And ideally, it should cover some diverse use cases that you want this kind of general model to do. And then you can then fine tune your model. So train your model on this new data. Okay, so let's call this like supervised GPT. Okay, and so now what you're going to do is that you're going to take more data, but now you're going to get more examples of inputs, but you're not going to pay humans to get inputs. Instead, you're going to make the model generate multiple responses to those inputs. Okay, so now you have for every new input, you have say 10 different model predictions. And you're going to take those 10 model predictions and you get passed them to other humans who are then trained to rank them. So which prediction do you think is better than the other? And they will give you some sort of ordering. Okay. So now let's see where we are. So now we have this supervised GPT model, and we have this set of predictions on it with human rankings on which ones are the better or worse. Okay. So now we're going to train a separate model to do this classification. So what it will do is that it will assign to each prediction a score, and then you train the score so that it assigns a higher score to things which are ranked higher. Okay. So far so good? Or
Yeah.
Okay, good.
So far so good. I'll ask a bunch of questions after you're done with your explanation.
Yeah. Okay. And so this classifier is also bootstrapped or started from a GPT-like model, or some sort of pre-trained model as well, because so you wanted to have all of that accumulated knowledge as well. Okay. So now we have both our supervised GPT model, and we have this like classifier, right, or a ranker that tells you like how good a prediction is. And then finally, we then train a model to not just do the next prediction, but also try to generate samples which this reward model also says are really high quality. Okay, so we do this through reinforcement learning. And so if you do that, and then if you just keep training for a little bit longer, then you end up getting Instruct GPT.
Okay, so we supervise. So we still have a generative model, but now it's more domain specific in the sense it's more tuned to the task of answering a question.
Yeah, correct.
And you can. So how would you actually output multiple different responses? Would it be like the typical beam search type of thing, or something different?
So I think you have a choice, but generally, if you want, like what people do is that you sample from the model. So all these models really output a probability for the next word. So once you have probabilities, you can just like sample. You can use those probabilities as actual probabilities and sample through. I think if you just do naive sampling, you may run into issues. Some people have explored using alternative sampling methods, but I think like at a high level, you can just sample from this distribution and generate potentially diverse answers. That's
interesting, because if you're asking a question, that's kind of, you want the model to be truthful in the end. So it's kind of interesting to think of all these different responses that could possibly be generated and how actually honest they'll be.
I mean, so one thing to keep in mind is that who knows, like, I mean, so you may generate, so you can create a model multiple times, right? But that doesn't mean the model will give you different answers, right? So like if there's only one answer in the model that assigns like 99.99% probability, right? And if you sample it 10 times, it'll probably give you the same thing 10 times, right? So there's no guarantee that these answers are necessarily distinct. So and in fact, I would imagine for a lot of cases where the answer is one clear thing, then it'll probably be the same thing like multiple times. But there are cases where maybe there are multiple correct answers, or maybe the answer itself can be like stylized in different ways. So for example, like if you're doing like lead code, there might be multiple ways of solving like a lead code problem, or there might be multiple ways of making translations, or so on and so forth. So I think it makes sense that you might want to have some sort of flexibility in how you answer things.
Yeah. How is BERT trained and how is GPT trained? I guess that would be.
So at a high level, the data is the same, right? It's definitely not, but it's just like coming from the internet, right? But the way that the main distinction was that, so BERT, they want to say, here's some text, I'm gonna remove certain words, and I'm gonna have the model predict what are the missing words. And so this is quite nice because it's actually able to not only use the past to predict the word, but also the future. So you get these kind of bidirectional representations. This is in contrast to like GPT, which is only trained to just, given some words, predict the next word. So it can only use the past. But this is also how you would use this model in practice, right? When you're generating text, you only have the past. So it's more naturally aligned with actually just generating text rather than like filling in blanks.
Yeah. So with this frame, like with this question in mind of like, how do you achieve understanding? In the terms of like, okay, even like a very concrete example, like suppose you have some sort of document, you just want to classify like what kind of document is this? It's maybe some sort of text document. This in some sense takes some sort of understanding. Okay, that's not always the case, but so BERT has this one way of like, instead of generating text, they kind of like, remove a word from the sentence and ask you to predict what that word should be. And then GPT, so I guess the B in BERT, that's bidirectional, is that correct?
Correct, yeah, exactly.
And then the G in GPT is generative. So this is like a fundamental difference in that they just try to generate the next, word or token or character, whatever it may be. So what is your feeling on like which one achieves a better level of understanding, and maybe like why?
Yeah, so so the real answer to the question is it depends. So for example, BERT would achieve much better like performance than the GPT-1, right? And I think in general, we've seen that these models trained for understanding can be fine-tuned to perform tasks much better than the GPT family of models. And then, we can get really into the weeds here. But I think maybe the key point is that like there is some value in this like bidirectionality. Like it's not just like a philosophical idea. It actually does manifest in like gains. And we see that like if you are allowed to fine tune, then most of these like bidirectional models actually do benefit a lot from this bidirectionality. So from that perspective, you would say something like BERT is better. But at the same time, BERT requires fine tuning. It doesn't work out of the box. Like you can try to hack it. You can try to use representations this way, but as is, they're just representations. Versus something like GPT kind of works out of the box, if you would. And so there have been some work trying to explore like what lies in the middle. Like, can you train models in like a mix of BERT and GPT, and what does that buy you? So, like you said, the best of both worlds or the worst of both worlds. And I think people are generally now growing more in line with the idea that, this might actually be a good idea. This might actually generate. And then some of the more recent learning objectives do try to like capture like both of these ideas, both infilling and also just like next token prediction. It's just hard, right? It's just because it takes a lot of time to train these large models. So actually verifying that these new ideas can work is just like very expensive. And so people are less eager to explore those directions.
Instruct GPT is built on the GPT series, right?
Yeah.
So there's GPT 1, 2, and 3.
Yeah.
What is it, the purpose of GPT? What is like the goal? Like if GPT performed perfectly, what would have been achieved? That kind of thing.
Yeah, sure. I think it's hard to say if there's like one like clear goal of like the GPT series other than say like build AGI, like whatever that may entail. I think maybe like at the beginning, perhaps a more concrete goal is say like, can we just can we use self-supervised learning as a way for like knowledge acquisition? Can we just train models with large corpora, and does it actually learn the knowledge from this corpora? So I think GPT was like the competitor, if you would, to something like BERT, where they also explored the same idea. But the exciting part about GPT versus a BERT was that GPT was a generative model. So like not only did it understand the world, but it had you had some ways of getting it to generate, and BERT just could not do that. People tried it. They had a few papers that tried to get it to like generate, but it just like wasn't built in a way that could really generate text. versus GPT naturally, had this next token prediction setup. So, does that make sense? Or
yeah, I guess I'd be interested. So can you explain a bit this sentiment neuron and how this kind of fit into everything?
Yeah, so I think this sort of goes back to more like, okay, so these models have in some sense a lot of latent knowledge, right? And so one way to test this knowledge is to say, okay, can we get it to do certain tasks? Right? And then maybe we can craft it into a prompt to have the model generate things correctly. But one other way of saying is that can we actually do some sort of more how would you say, can we actually look at the model weights and use that, those representations to actually figure something out? So I may be misremembering the details for the sentiment neuron. It's been a while since I thought about that work. But I think the interesting part there was that they were actually examining the representations of text using the neurons of GPT-1 or GPT-2, one of those. And what they found was that, and then they wanted to train a classifier based on those representations. So you give a text and all it has access to is the neurons as the representations. So then they train a classifier based on these neurons. And then they had a very strong L1 penalty. So that it would only try to, it would want to zero out many of these neurons and only keep the important ones. And what they found was that there was one neuron that was actually the value of this particular neuron is heavily correlated with the sentiment of text. So somehow the model encoded the sentiment, or maybe sentiment was encoded within this particular scalar value, which is pretty surprising. Why would the model think this is an important thing to store? Yeah, it's not even trained to talk about sentiment or even know about sentiment, but somehow it said, okay, I'm going to store this kind of information primarily in this neuron.
So you have this fine-tuned model. It's good at following instructions. So then, what's the point of adding a reinforcement learning on top of this? How does this help make the model that much better?
Oh yeah, right. So you mean why? Yeah, what after fine-tuning, after you get this result, why do we need an additional RL component on top? Yeah, I think that's a good question. And a priori, it's not super obvious why you would want it. I mean, so reinforcement learning has a bunch of issues. It's generally kind of unstable. These have high variance. These don't usually work. It's very finicky. Blah 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 blah. And the supervised fine-tuned models are already better than the base models. So it's just a priori not obvious why you would want to do this, right? But I think maybe the simplest answer is that it just works better, right? So they had this plot in the paper where they showed that the smallest model at the 1 billion scale was performing competitively with the largest model, the largest supervised model. So this already saves you orders of magnitude of compute. It's much faster, easier to serve. It just works better by a large amount. It's unignorable how much better it is. And so now, why is that the case? At least to me, it's not completely obvious. I think there's a lot of discussion as to there's a lot of hypotheses and whatnot, but I haven't seen a compelling argument as to why we should expect this to be better.
Oh, interesting. So I guess, okay, with that in mind, we'll think about why it should be better. Can you explain a bit how it actually works? So how to use reinforcement learning to improve the model?
Yeah, certainly. So I think maybe one interesting difference from just the supervised fine-tuning aspect is that you're also doing RL, you take some sort of prefix, that's it, and then you have the model actually generate continuation, right? And you have each continuation is scored by your let's say your rater, right? The model that you train to score predictions. And so now the model, this is actually a unique kind of setting where the model is actually trained on its own predictions, right? So, right. It's actually you're actually creating new data, and so that may be outside of the distribution of things that you had answers for. Moreover, it's actually because it's rated, it's not just a score about whether this data was likely or not, but it also gets weighted by its rating according to your model. So now this is a new reward signal that's not just next token prediction or just trying to match what the humans taught you. It's actually trying to go beyond that, I'm really good. What is the space of high quality answers look like?
I guess one thing, so you mentioned this, so I guess I saw this as well, the difference between like the capabilities of the ML model versus the alignment.
Yeah.
So like the capability being like the technology that goes at like making the ML model better at like lowering a loss function or that kind of thing, whereas alignment being like actually figuring out what the right loss function should be or something like this. So I guess what I want to ask is, okay, so when do you think was the point where like alignment was really something that people thought was interesting and also maybe even worth pursuing?
Yeah, so I mean, I should definitely say that like I think a lot of there's a lot of folks that have always been interested in alignment, right? And even a lot of like very like smart people, and even within like the ML community, I think it just only became popular, or maybe more mainstream, I should say, after like these works came out. Kind of this idea of like learning to summarize using human feedback, and even the Instruct GPT. I think people were in general excited by this idea of just leverage human purposes. Like the idea of human purposes as a thing to use, of course, is like pretty old. But this idea of combining that with this like philosophical idea of alignment models, I think only became really popular because of like things like Instruct GPT.
It's still interesting. Yeah, it is interesting. You mentioned earlier that there was this like 1 billion parameter model that, that was like that they trained using these techniques, and it compete with the 175 billion parameter model that they didn't really train using these techniques, just the previous, and they're comparable. It's kind of interesting that they could basically trade in computational resources of like the model to like basically human compute, and saying that it's probably a bit more efficient in that way.
Yeah, I mean, like, don't get me wrong. At some point, like, the model that like the biggest model that was also trained with this technique is the best one, right? So like, it is not saying that like making models bigger is a bad idea necessarily, right? But it is saying that at some point, doing things that are not just training large models or the training, like not just doing self-supervised learning, but doing something on top of this can actually give you like monumental gains.
I think we should call it.
Okay.
We'll probably talk again, but yeah, this is good.
Sounds good, man.
If you have any questions that you would like to ask, feel free to leave them in the comments below, and we'll probably address it in a future video.